introduce the audience to who we are and what we do.
Thank you, Jeff. Welcome, everyone, and good afternoon, good morning, good evening. See, people have signed in from pretty much all over the world here. So thank you for making time for the webinar, understanding what BioPCM is and what Phase Change Solutions is all about. Thrilled to have you all here. What is PCS and who are we? As a way of introduction, PCS has actually been providing solutions for managing temperature in multiple use cases. And look at us as a materials company, advanced materials company that's focused today on phase change materials that alter temperature. And we're focusing on managing temperature in small environments like packaging, shippers, et cetera, and also in large buildings, et cetera. So it's both temperature management and decarbonization. And PCS as a company has actually been in existence for over 10 years. However, we've been working at it, the team has been at it for over 2 decades, doing research on core materials. So that's the significant advantage of what we bring to the table. That's our core. So today we'll talk a little bit about where we are focused on, why we're doing this, and also how this can help people across the value chain, companies across the value chain, specifically in cold chain. So our focus is currently, even though we focus excessively on cold chain, refrigeration, and mobility, our solutions are also applicable for use in buildings, in energy efficiency and storage. As an example, for telecom and data centers in lowering energy consumption. Today, we'll talk a lot about the sustainable cold chain and how BioPCM, which is our platform, technology platform for advanced materials, how that's applicable for a variety of applications in cold chain. So that's going to be our focus here today. We are based in North Carolina. We have offices, satellite offices around the world. Actually, we're all establishing more presence in different parts of the world. For example, in Europe, in Asia, et cetera. Our philosophy is to partner with companies with what we call adjacent capabilities, so we can actually get the BioPCM solution to the marketplace quicker, faster, and more efficiently. So what is BioPCM? So let me introduce to you the concept of BioPCM, the platform, and what it is, et cetera. And then we'll go into, Reyad will take you into the details of how it works and why we believe this is actually such a perfect solution, a sustainable solution for cold chain, et cetera. So if you take BioPCM, the core of it, this is a chemistry which I talked about, has been in development for over 20 years and has a over 10-year performance record, right? So this is, the feedstock is from naturally available materials and byproducts of existing processes. We'll go into greater detail as we talk about our concept of why we believe making it locally is going to be a significant advantage for customers and end users alike. It's also highly compatible. It can blend in with platforms, whether it's fluoropolymers, acrylics, urethanes, et cetera, because we now know that the cold chain uses current materials in shipping material from a place to place to a payload. And being able to integrate with existing platforms, it's a huge benefit so that manufacturers don't have to change their existing processes. It actually lowers cost of production, et cetera. And one of the trends that we've been actually tracking and following from the time PCS was started is this whole concept of sustainability and circular economy. As we said, the feedstock is from naturally available sources. It also is available everywhere in the world, so we can actually source material locally to manufacture these products. We have a low capex manufacturing process, so we can partner with OEMs who are able to actually make this modular design in different parts of the world. And as Reyad will talk in greater detail of how this technology platform works, the future proofing of this includes things like tunability, being non-corrosive, non-toxic, et cetera. And last but not least, our engineering capability in the company, in addition to the chemistry aspect of it, provides us with the ability to bring this up in various form factors. So, and that's the significant advantage that we bring to the table. Reyad, can you kind of elaborate on this a little bit further and kind of attach on the points, key points, especially the feedstock, the adaptability, the engineering aspect of it, and then we can talk about how this works as well.
Yes, so Govi, thank you, and good day to, I see many friends and colleagues and from all over around the world have joined us. Great to be talking with you today and describe what we have. Our technology platform, as Govi described, as we refer to it as the BioPCM, which based on plant-based materials that we either take from naturally available resources from plant extracts or vegetable oils and many others, or in many cases where we also, instead of taking from virgin materials, we take from byproducts of the food industry, because from day one, the company was established to produce environmentally friendly products as well as human-friendly products, where we don't take parts from components from the food chain and convert them into shipping or building materials. So based on that premise, we have restricted most of our feedstocks to not only be from natural resources, but from the non-edible part of the food chain. This is why, as you see here on our list, byproducts is a big component of what we do. The second point that I would like to elaborate on, since this technology has been in deployment now for over 15 years in many applications, I think a major differentiation between this class of phase change materials and many of other classes of phase change materials that our people are used to, because as a smart material science company, we can engineer products. We literally can engineer products by building the carbon hydrogen chain blocks as needed, by taking natural ingredients, natural blocks, and pack them to produce two features. One, which is the most important, the energy density at the right temperature, because you don't want to have an energy density distributed over a large range of temperature or a wide range of temperature. As you will see later as we go through the presentation and so on, you will see that many of these features will stand out for you on their own.
Great. Thanks, Reyad. So, Jeff, in talking through BioPCM, right? I mean, do you have other points, Jeff, you wanted to add to the commercial viability of the product line, et cetera?
Yeah, so Reyad, with what we have now, our commercial products now, in having worked in the cold chain industry, there's always concerns regarding corrosiveness, toxicity, and particularly the recyclability of PCM. Can you speak about this a little bit?
Yes, absolutely. So in general, as you know, people in the industry, when we talk about phase change materials, what comes to mind are three classes of materials. One is salt hydrates, which are commonly available, readily available in many parts of the world, and they have been used for a certain number of applications. Some of these salts are corrosive when they are packaged in specific materials, especially when it comes into the interaction of salt hydrates with metals. Some other materials are also, they are not compatible with certain types of plastics or packaging. Mm-hmm. So they leach through these materials, and eventually, as they leach through the materials that they are packaged in, such as HDPE or linear density or high density polyethylene packaging, that presents a problem not only from the package itself, but also to the payload. Imagine you have $1 million medicine for treatment of a specific cure, and then you have the product that is supposed to protect it at the right temperature leaching into that package and then rendering it inactive or not safe to be handled by humans or to be given to humans or animals. So the third class usually people are familiar with is the plant-based. Not all plant-based materials are also, I would say, they are less corrosive, less problematic than petroleum-based products, and less than salt hydrates. However, if you know what is the functionality or the functional group with these plant-based materials, you could go and terminate the reactive groups to make them more inert, to become more compatible with any package you put them. And this is the beauty of engineered materials, despite the fact everything is from natural sources, but we engineer it in such a way where it's still active at the thermal level, but inactive chemically.
So, Reyad, I think then this sort of takes us to the concept of being the tunability part of it, along with the engineering capability, provides us with a range of solutions for cold chain, correct? That's one of the advantages that we want to talk about today. Right? Can you address a little bit of that as well?
Yeah, I think today, as many of our friends who are on this call are aware, we have applications ranging from minus 75 degrees C to 107 to plus 175 degrees C, and anywhere in between. So commercial here on this list, as an example on the slide, these are commercial products, BioPCM commercial products that range from minus 65 to plus 135 that are used in many applications from shipments of cell and gene therapy, pharmaceuticals, biologics, fresh fruits and vegetables, human organs, as well as maintaining temperatures in warehouses or data centers or offices or homes. The fact that we can manufacture product today between minus 75 and plus 175 does not mean that's the whole range of what we manufacture. We can actually manufacture way beyond that. We can give products minus 120 if the application is needed. But what is really there is not the ability just to say, I have a product at minus 75, another one at a plus 135. The tunability of the technology platform where you can specifically design any temperature based on the required application. If, as we talk today about new technologies, mRNA, and many clinical trials that are on the market today, if you look at 9 out of 10 clinical trials are going to require specific temperature ranges. And that's the beauty of the BioPCM technology platform. If somebody wants a minus 43.7 or a minus 17.9 or a plus 5.9, we can dial that transition temperature to a fraction of a degree without compromising much of the value of the product in terms of its energy density and thermal physical properties.
Yeah. So, Reyad, on that topic, where do you see the next frontier in the needs of the marketplace with PCMs?
Well, there are many applications. Of course, since we are talking about cold chain, I'm going to focus on cold chain and just say a little bit about some of the other frontiers that have emerged in the last year or two, as an example, such as in electric mobility, in drone application, in aviation, and so on. But since we are talking about cold chain, the market has been focused on 3 temperature ranges. Mainly the dominant in North America is the refrigerated market. The 2 to 8 range has been the dominant part of the cold chain application for pharmaceuticals and biologics and medicine. And then you have the frozen range, which is typically anywhere from 0 to minus 25 or minus 15 to minus 25. And the CRT, the room temperature application, 15 to 25. But in the last year or so, as we saw the advances in technology based on mRNA for the development of vaccines for COVID-19, and that technology has been proven extremely effective of coming up with vaccines to deal with diseases such as the pandemic we dealt with in a short period of time. Many companies went and now expanded their offering on the mRNA technology to come up with cures for cancer and diabetes and many others. So I think the biggest, in my mind right now, the biggest interest, as I have seen it in the last few months, has been focusing on cell and gene therapy in addition to the existing market. And this is why PCS as a company, we immediately took our technology platform and deployed it very effectively to meet the demands of vaccines in the minus 25, minus 20, minus 25 for Moderna-like vaccines and minus 65 for the Pfizer vaccines, with applications, as some of you might know, that have been delivered with drones or with conventional shipping or air shipping.
So Reyad, just to hone in on that just a little bit. I mean, there are many solutions that get to minus 40, minus 60, minus 20. degrees here. And we are seeing this trend increase, especially now with the newer cell and gene therapy that's actually coming. Even today's announcement from South Africa is trying to provide cold storage, freezers 20 degrees below, where they can actually store pharmaceuticals and test equipment, et cetera. The difference between what others can do and the solutions that BioPCM provides is also not only providing with the fine-tuned temperature maintenance, but also how we do that with solutions that are fully considering the circular economy concepts and sustainability. And that's one of the significant advantages that we talked about, right? And can you, Jeff, I know we have talked about this before, commercially available solutions today that are not only sustainable and in consideration of circular economy concepts, they're also economically viable, right? From a total cost of ownership perspective. So Reyad, maybe we should probably address that as well, a little bit as well, like doing it right now.
Yeah, as you know, I mean, when we talk about lower temperatures than -65, dry ice is the darling of this type of application because of its energy density, its cost, and so on. But the fact that dry ice is a single-use product and you generate tremendous amount of CO2 as these packages are transported from one location to another, you have limited number of packages that can be put on a commercial or on certain aircrafts, as an example. And so the idea here, can we make a product that, I'm not going to claim here that we have the same energy density as dry ice, but we have the same thermal profile with maybe half of the energy density of the dry ice, but it can be used again and again. So you either in places like in certain parts of the world, where you don't have the ability to get the dry ice in quantities that are needed in a timely manner. In this case, I think BioPCM comes extremely effective, where you can take phase change materials and apply it, and you have a -60 or a -70, -75 solution that you could use again and again. And this, as you know, Govi, in our discussions with the World Health Organization, with the Gavi alliances, this is in bad need in many parts of the world, not only in areas where certain refrigerations or freezer requirements or commercial offerings are not available, but also the fact if you could still use some dry ice, but you could cut it into half or 10% and utilize BioPCM to be carrying the rest of the load, where the dry ice not only can maintain the package for the first the first part of the journey, and that energy would be used to condition the PCM, and the PCM will preserve it and carry it for the remainder part of the ride. The beauty of it, it's all made out of natural materials, and if you want to dispose it, you can dispose it in the regular means according to locales and locales policy. And I think I'm comfortable here also sharing with on this webinar that as we will be offering new solutions that will eliminate or reduce the amount of plastics or eliminate totally the plastic packaging that the phase change material will be wrapped in, where the whole thing, since we are talking about materials that are come from the food or the non-edible part of the food chain, which are 100% biodegradable, the entire package would be 100% biodegradable to meet our commitments to circular economy and our commitments that we have made for ourselves, our shareholders, and also to the world and the environment.
That's great. Thanks, Reyad. Go ahead, Jeff.
Yeah, so could maybe talk a little bit about the science of the BioPCM and the tunability of, the current products that we're offering?
Yeah, I think the science, for those who are familiar with the aspects, I mean, it's really, in this case, we are talking about combination of material science. It's material science at best. So where you combine physics and chemistry, biology, engineering, nutrition, you learn from Mother Nature. Mother Nature has invented the best phase change materials in the world and will continue to do so. So you just learn what Mother Nature has been able to offer us and teach us, and we take from there and we build on it, and we just make mimics mimetics of products that are mimicking Mother Nature's application in these. So we talked about the feedstocks, which are naturally occurring, as Govi said, can be purchased local to local, where we can meet the Asian market from Asia and the Middle East from the Middle East and North America from locally sourced material. But also, I think now when you take the material science and trying to build these one molecule at a time, where you, as we said, if we wanted to come up with a specific transition temperature, after all, the governing law or rule is the number of carbon-hydrogen chains, of course, but then the energy density is not only governed by the carbon-hydrogen chains, by the absolute number, the way they are stacked. And that's where we have built the technology platform over the past 15 years or so to build a library which has thousands of combinations that will allow us to come and using computational modeling tools that we can meet the needs of our customers in hours or days, not weeks or years, to be able to deliver a new specific products with specific parameters.
Yeah, and as this visual shows here, yeah, this is exactly what we're talking about. Temperatures between 24, and 168 hours. We're also in form factors, right? Solid to solid, solid to gel. So that gives us the flexibility. And if you look at the range here, from what we've done already, right? The refrigerated, the sub-zero, the frozen, and there are specific applications here, Jeff and Reyad, that we've actually been working on more than the others that are commercially viable today. And based on needs, even in current markets, both here in North America, also in Europe and Asia and other parts of the world, that I think is a key takeaway for our viewers and listeners and participants here, is that form factor, the time, 24, 168 hours, and solutions that are available today for us. Is that right, Reyad? Jeff,
it is. And thank you for bringing this one. You just reminded me of as we look at this, because when you look at temperature maintained from 24 to 168 hours, the main factor here is with also the ability to maintain the maximum payload that you can have within a specific package. Because when we talk about phase change materials, many times a lot of people overlook certain properties which are really important in this factor. So we talk about what temperature does it melt at and what temperature does it freeze at? What's the energy density? But imagine when you talk about energy density, the energy density is joules per gram or joules per unit volume. The fact we engineered our smart BioPCMs, it gives us the ability to not only fine-tune the transition temperature, but also the density, the energy density within a unit volume. So if somebody, as an example, as you look at this box, and you see I have to have a payload which is 10 liters, but right now my solutions can only give me 96 hours. I don't want to reinvent the wheel. I don't want to design a new package. I want to get it to 120 hours or 144 or 168. It's simple for us at BioPCM. What we can do, we can engineer the energy density per unit volume in a bottle that takes 1 liter. We can put anywhere from 700 grams to 1,000, from 700 grams to 1,600, 1,700 grams. We can put twice as much materials in the same volume. That, and if you maintain the joules per gram, now you double your energy density within the same volume, or you triple that in some cases. And this is why I think as we engineer these materials, we in the new offerings we just released recently, or for some of these classes, we can modulate and easily double the energy density within the same volume in bricks, in pillows, in bottles, and many, to allow our partners to extend their range or to replace an expensive component such as a vacuum insulated panel by an expanded polypropylene or polystyrene or a more friendly packaging such as cellulose. So you could take something that is designed for 24 to 40 hours and make it 120 hours without having to go and put an expensive packaging around it.
Yeah, and I know there's a lot of recycle with sustainability. There's a lot of reuse, and there's a lot of single use. And something that we have a video of is we can show you is something where we actually manufacture the bricks, so we can show this to you as well.
Yeah, I think this is an important thing, that also another distinction for phase change solutions, that look, you are looking here at a video showing that we are extruding phase change materials as they come from an extruder above 75 degrees Celsius. In this case, as an example, it could be anywhere from 75 to 120 degrees C based on the material that we are extruding, showing that you have a 4 degrees C coming in a solid form that's being cut into the proper dimensions that are needed to maintain a specific package. If you want 8 by 12 or 5 by 7, not only our extrusion processes allow us to do this, we're slowing the process here just to show the video to give you a glimpse of how it's being made. But this really travels extremely fast, where we control the weight and all the dimensions. And at the end of the line, we have a zero waste policy. Anything that does not fit the requirement gets back in the loop to the harbor and reprocess again. We're showing two different videos here. One showing you, again, this is when you increase the temperature even further and show that a translucent block, again, you're talking about 5, 6 degrees C here at almost above 100 degrees C, maintaining its shape in its fully translucent manner. And once it goes into below the transition temperature it was designed to, it could be opaque or a little bit harder. But this is something today that PCS offers that distinguishes us from many of our competitors. We can give you the product in liquid or gel or solid to solid form at any temperature ranging from minus 75 degrees C and upward.
Thanks, Reyad. I appreciate that. And I'd like to just touch on something else that's unique to phase change materials, and that's dual temperature phase change materials. Reyad, could you explain, how it typically works in the cold chain industry today, and how the BioPCM platform is designed, and how does that compare?
Yeah, so many in the cold chain industry, in any industry, as an example, it doesn't really have to be in the cold chain, but in a building application or telecom or the cold chain, since we are here focusing, we're showing examples where in case you wanted to buffer a material not to go below a specific temperature and not above another with universal backout, where you don't have to worry about having rules for the summer that are different than what you follow in the winter. And I'm not talking about here taking two packages and put them together where you have one with 18 degrees Celsius and one with 23. Since we're talking about smart materials and engineered materials, we can design that material to have two transition components, two phases, one at 18 and one at 23, that can all coexist and survive for tens of thousands of cycles. This is true for any temperature combination we have, from the frozen to the higher temperature. And the reason why this is important, again, one single pack out with universal packaging, summer and winter, eliminating the need for many SKUs. So for CRT, some people use 16 and 22, or 18 and 23, or 24. By having an 18 and 23 or a 17 and 21, it doesn't have to be 18 and 23. My point here, it can be any combinations of temperature your current protocol is using, and we can design it for your application without you having to go and re-engineer your process and do new qualifications, full-fledged qualification. All what you have to do, show equivalency and run your ST7D and show that you are not only meeting but also exceeding your current requirement. I think this is a feature that's extremely important in cold chain applications, as we noticed from our partners. Once they start using it, help them eliminate many SKUs. Energy density is extremely high in these dual temperatures. The other one, as we talked about cell and gene therapy, the one far to the right, you could have a combination where you say minus 20 or minus 65 or anywhere in between. They can be the two distinct phases, or actually one phase with a tail peaking again at another temperature, again based on what freezers are available. So if you have limited freezing capabilities, we can design this to be minus 40 and minus 20, or minus 20 and minus 35, and so on. Total flexibility for the dual temperature properties that we have in our BioPCMs.
No, that's excellent. So, we've talked about the attributes of BioPCM and the products we offer. So, Govi, let's switch over and talk about the benefits of BioPCM and really how that impacts our customers and how they do business.
Yeah, absolutely. And while we're on the topic there, Jeff, about the benefits, I do want to sort of address one point that Riyadh made on energy density and talk about thermal mass, etc. Because one of the questions that we have received is how do we estimate the weight of our product? And Riyadh, I know there are significant cost advantages, total cost of ownership and cost advantages of using BioPCM, especially if you're looking for tunability of the temperature across a time period. Riyadh, can you address before we just leave the slide on from a how do we actually talk about the estimating the weight of the product and more with relation to cold storage, does it really make a difference in cold storage warehouse or is weight, and weight is a key aspect of transportation. How does it make a difference and impact on in cold storage homes?
Yeah, I think based on the application, we always say every problem can be solved once you know the boundary conditions that you are trying to solve for. So if we are talking about aviation as an example or drones applications, mass is extremely important. Weight, the heavier the product, the higher the penalty is. So here by BCMs, we can offer products today at 200 joules per gram or a 300 joules per gram. However, of course, the price or the cost of a 300 joules per gram is much higher than that of a 200 joules per gram. However, if that gives you the duration that you are looking for without having to pay a heavy penalty on fuel for aviation or drones or for transportation, or if it's an overnight envelope, then it pays for itself from the beginning. So the way we calculate the needed amount is based on the boundary conditions for the problem we are applying to. If it's a 24-hour envelope that we need to minimize the weight as much as possible, then instead of putting 2 pounds of material at 170 joules per gram, we could cut that weight by half by doubling the energy density in a thinner membrane that we then, and then the same thing in a warehouse. Again, in stationary applications such as warehouses and buildings, weight is not an issue. Cost is an issue, and return on investment is an issue. This is where the form factor becomes, is it part of a secondary product that you have to offer in addition to what's being required, or can you integrate that within a primary application, such as we are doing today, infuse BCMs in foams, infuse BCM in rubber membranes for roofing applications and others. So the way we calculate, of course, computational modeling, thermal simulation, where we look for what is being required from a duration or energy saving, we adjust the thermal physical properties of the material and we prescribe it accordingly.
Yeah, and thanks, Riyadh. Thank you. So it's also probably good to note to our listeners here and the participants, we have the ability to help model the requirement for any application. So that's the other advantage of actually what we provide. It's not just the product and the engineering, it's also the modeling of what is required. So that's a kind of a partnership that we're also beginning to develop, and capabilities in-house, both digital but also with people. So Jeff, I know you asked about the applications and versatility. We are interested in managing temperature across from end to end, right? So first mile to last mile and everything in between. Because BioPCM is so fungible, we can also have this in storage warehouses, in refrigerators, as an example. It's a perfect example of how pharmacies and distribution centers and hospitals are using BioPCM-based solutions in refrigeration. So here you see an example of refrigerator shelves that can also be used in freezers, right? We can toggle the temperature. And there's a specific example of a pharmacy chain that has saved, a little over $350,000 a year in one site, largely by avoiding wastage of medicines which had to get thrown away because of brownout. So irrespective of whether if the refrigerator goes away, is not working because of a compressor failure, or if there's a power failure, your temperature is maintained. And I think, Reyad, we have data here that shows up to 6 to 8 hours. Is that the
Oh,
one?
I think what we,
The
as you said,
14-hour part is.
Govi, we have these shelves which are deployed in both refrigerators and freezers. This showing our refrigeration shelves in a refrigerator, showing that the refrigerators that don't have our shelves reached 8 degrees C, where is the cutoff, within 1 hour. While the same refrigerator with BioPCM or Apollo panels were able to maintain their temperature for 14 hours. Imagine if this power interruption or failure happened at midnight. So you have to send a crew to move the medicine or fix the refrigerator. Knowing that you can have up to 14 hours, then you could deal with it the second day. And this is now have been approved in certain parts of the world as a second or an option for backup, the same way you use UPS or a generator. In certain countries, we have partners that they have lobbied and consider adding the BioPCM Apollo shelves in their refrigerators or freezers be considered as a backup option.
Yeah, and thank you, Reyad. Thank you. So it's 14 hours, 8 degrees C. That's proven. So the question here is now not only from shippers, pallets, first mile to last mile, and storage and refrigerators, et cetera, which is unique, right? This now reduces wastage in the pharmaceutical industry, in the cold chain, significantly. Let's maybe talk about, so why BioPCM in cold chain? And these are solid examples here specifically. So if you want to, let's take a little bit of detail into why this makes more sense in cold chain in particular, right? So Jeffrey, do you want to just kind of cover through? So if you take a look at the characteristics on the left, right, the temperature range, density, tunability that we've talked about as a summary, how this impacts and how this helps customers across the value chain, right? Not just people who are 3PL companies that are interested in shipping, but also in pharmacies, in pharmaceutical companies, in hospitals, et cetera. That's a unique value proposition, right? So Reyad, you can address some of this stuff as a summary, right? How we have actually been able to position this product core, which is BioPCM.
We already talked about the ability to fine-tune and come up and design any temperature within a fraction of a degree. Like if we focus on refrigeration, 2, 4, 5, 6, 7, 8 are all possible, and today we are offering all these combinations. But what on this particular one, which is also really important, there are more refrigerators in the world than there are freezers, especially in distribution centers. So if a customer wants to use BioPCM as the only solution and they would like to have it conditioned and brought to the design temperature in a refrigerator, we have a 5 and a 6 degrees C. They can be conditioned in a refrigerator where there is no need to put them in a minus 20 degrees, and that allowed them to do automated robotic back out where you don't have to wait 10 to 15 minutes or 30 minutes to take them from a minus 20 to bring them with a payload at 5 degrees C, and that to eliminate cold shock. And however, we offer both. We offer a 4 and a 5 that can be conditioned in a freezer and melt at 4 and 5. We offer the same for refrigerator. So temperature optimization is extremely important, not only from their energy density and extending the duration, but also from the automation process. As we all know, automation is becoming crucial more and more in everyday life application. And if you are talking about the McKessons and the Cardinal Healthcare and AmerisourceBergen and the like, every second counts when you are dealing with millions or hundreds of millions of packages. The energy density, as we talked about, the ability to be able to design an energy density. We all know that water is the gold standard for cold chain application with something like 334 joules per gram. So phase change materials which are commercially available have not come and really exceeded this from a joule per gram perspective. However, engineered phase change material, because if you take a 1 liter and fill it with water with a density of 1, that's 334 kilojoule in that liter. If we have a phase change material that has 250 kilojoule per kilogram, but a density of 1.5, that becomes 375, and that's more than water. So the ability to exceed that gold standard without having to go and put a very expensive feedstock by modulating the energy density and have it in a stable and in a form that does not go through a volume change is extremely important. The tunability, we talked about it. It allows us to not only optimize the temperature that we need, but also the package design. You could go from a 2-inch urethane foam to 1.5 if you have the right energy density. The main thing is always the payload. Ship the maximum payload to allow it to get to its destination at the lowest cost. The dual temperature, as we talked about, is a unique feature for us as well that will allow us to help our partners to eliminate many SKUs and have only one for a particular range, such as the 15 to 25 or the 2 to 8. And one, I mean, again, the other favorite for me is the bio-based and the sustainability, the circular economy aspect, that you are dealing with natural materials that are part of the non-edible food chain, but yet we are now only after, say, a few decades that we are now able to move and replace those packaging materials into something that also have the same criteria as the material, that the core material. So we have an active that's biodegradable on its own. It's in a plastic package. You have to slash it, take the material. It biodegrades on its own in the landfill or in your backyard, but the plastic that's around it, it doesn't. Now with BioPCM eliminating the need for fluorination, no need for EVOH barriers that is commonly used for oils such as paraffins and even some plant-based oils as well, that the elimination of fluorination is one of the biggest factor that's going to have significant improvement on the sustainability aspects of phase change materials in cold chain. As we know, fluorination is, we have limited places that can provide fluorination, and now fluorination companies that do fluorination, which you could count them on your fingers of one hand, are facing scrutiny from the Department of Energy, from the EPA for preventing some of this. So now with BioPCM, no need for fluorination, no need for special packaging. You could package BioPCM water-based or oil-based in the same film. And that's a huge factor. This is a good demonstration showing if you use a product that needs fluorination, if you put it in a package that is not fluorinated, you are going to lose, as a function of time, a specific percentage of its weight. I'm just giving you here, we're giving a very conservative estimate, 6% in certain package, but in many cases it will be more than that. While with BioPCM, you could maintain it at the same weight for here, the example is shown 2.5 years. We can even show that beyond that. So the elimination of fluorination, the biodegradability aspects of the BioPCM, and also the packaging that around them allow us to meet all circular economy requirements that not only us, but our partners and big corporations have been thriving to get.
So Reyad, if we summarize this, right, Jeff talked about this. Go back one slide just to summarize the benefits, right? This is the benefit of BioPCM, where optimizing raw material, supply chain, building into consideration the energy density to optimize payloads, right? So you have higher percentage of active materials. Of course, the tunability aspect of it, giving you the flexibility of temperatures. And then, of course, you're talking about duration and higher temperature control as well. And finally, and last but not least, as Reyad, we just talked about, with no more fluorination, right? And you're avoiding EVOH. These are significant benefits that go to the bottom line when people start packaging, and providing system design in terms of the overall cost and temperature management across the board. So this is critical for us to make sure that the value proposition is ideal. And again, not just for people who are designing shippers, right? So this goes across the value chain. So now if we take this BioPCM and see how this helps each part of the value chain, starting from the manufacturer of pharmaceuticals, people involved in the first mile transportation part of it. Then you talk about folks who are storing and distribution, and then going to the last mile delivery until it reaches the end user or customer. Each aspect of this, BioPCM brings a significant advantage from fine-tuning the flexibility of product. So as soon as you manufacture, how do you store it, where you store it, have the flexibility of temperatures. And then for first mile transportation, is in terms of optimizing the payload, you reduce waste, and of course, significant fuel savings, especially now as people are going to EVs, and mobility is becoming a huge aspect of it because, of course, they cannot idle some of these trucks in multiple, in various cities. So now you take that, now you're getting the distribution aspect of it, where BioPCM in multiple form factors can also lower your air conditioning cost, can increase your pack out, as Reyad and Jeff were talking about before, and then taking it finally to last mile delivery, where you can, of course, increase the size of your payload, reduce freight cost. Each aspect of it, BioPCM brings significant advantage. And of course, Reyad, you mentioned before about this whole concept of single use, multiple use, etc. Because of our material selection, that provides a significant ESG goals, the ability for people to build in their ESG goals, whether it's for decarbonization or for cost reduction and making sure that they're not eliminating waste. So, Jeff, is there specifics that we should be addressing given the current value prop today of BioPCM that would meet the needs, especially as we are hearing from some of our customers?
So one thing I'd like to talk about too, because we're running a little short on time, I want to leave some time open for questions as well, is, if I'm a company looking to design a new product or solve a specific challenge, right? And how do I start with PCS? And how can PCS help?
Yeah. So in each of these solutions in here, Jeff, we actually have, as Reyad talked about, the ability to design material. So our capability to understand the need is quite high as we study the application specifically, because we have our modeling capabilities. And with our library of materials that we have developed, formulations that we've developed, as we talked about in the very first slide, we are over 20 years, 2 decades of experience in formulating materials. So the library is vast. So our ability to actually take basic what we call feedstock and combine it into formulations is going to be huge. So that capability to engineer formulations is huge. So now we think about, irrespective of your need, of course, we have demonstrated manufacturability and scale, and we're working with partners to take this down to the next level. It is state-of-the-art technology because as the temperature requirement evolves, whether it's with mRNA technology or with cell and gene therapy, looking at all of these needs for lower temperatures, we continue to refine the technology with better feedstock, better models to actually manufacture these, and also with chemistry. And we've also added application engineering capabilities. So how do you take this BioPCM, this capability, and how do you optimize product design? That is huge. It's not just that we're throwing chemistry over the wall. So we work with partners, whether it's 3PLs or whether it is OEM manufacturers, et cetera. We take the entire information from the value chain. And Reyad talked about this earlier before as well. And we are expanding our product testing capabilities, both in-house and also in partnerships with other companies as well. So we get to systems level testing, right? Not just the BioPCM. Take the entire system depending upon what standards you want to follow globally. We make sure that we're able to kind of provide the testing, and that the 2 or 3 things that are more core to us is quality. And this is a journey, as we call it. So we take on quality very seriously to not only lower the waste in our manufacturing, but also to reduce returns, and also in the value chain with customers. How can we actually improve quality, reduce downtime? So the engineering team is continuously working on improving the way of working even with customers as we go design new systems. And that's why the last bullet is in there in terms of having partnerships, the ability to take this BioPCM technology and partner with solution providers to enable your solutions. so that your capability is brought to the table as well as we engineer better materials that can fit in with your solution. And that's the goal, of course, we're talking about a circular economy, greener ecosystem, et cetera. And that is very, very, very important to us. And that's one of the reasons why we think partnering, it's not just the BioPCM platform, it's also the ability to partner and work in partnerships to take this to the next level. So Jeff, were you saying something in terms of adding to this about our partnerships, or Reyad, do you want to add anything to that in terms of our ability to work in partnerships?
Yeah, I think our ability to work in partnership is unique in many different ways, being, if not the only vertically integrated company in this space. Yes, you could go and buy phase change materials from a company X or a company Y, but there are not that many companies around the world that they can not only engineer a specific PCM or make it or integrate it in unique form factors and lending our technology intellectual property to allow our partners to even introduce smarter products. As we learn from our journey, we also notice there are shortcomings in multiple different offerings on the market. When we work with our partners, we say, yeah, I mean, this product can easily be improved by doing the following, and we work side by side. And we not only help in the design and the thermal simulation in the testing, but also we provide the final package product in the format that meets, like introducing corner filling, introducing a higher energy density per unit volume, integrating this in the packaging materials itself. And on top of all of that, something we missed in our discussion, our technology is also coupled with unique color change technology. So we also have phase change material that are one color while they are in the liquid state or above their transition, and they turn into another unique color below that transition to allow the packaging system, the distribution system everywhere to know that this is ready to be used or it needs a few more hours. So going from a blue to a white and a marble in between. These are all unique features that we work, and we continue to bring new innovation into the space to offer our partners more efficiency and more benefit into meeting their commitments to their partners.
Yeah, thank you.
Thank you.
Actually,
guys, we have a couple questions, so we have a few minutes left, so I'd like to address those. So the first question is, besides energy blankets, does Phase Change Solutions have other standard off-the-shelf products such as bricks or modules with embedded heat exchangers?
Yeah. So Jeff, let me jump in here. Yes, PCS, we do have standard off-the-shelf products like bricks, absolutely. We call them bricks, you can call them modules, you can call them pillows. What we don't do is have our own heat exchangers. We enable these to be embedded with other heat exchangers depending upon the application that you actually work with. We help you design that part. So that's one question. I hope I answered that question. And yes, if you go on our website and reach out to Jeff, you can provide information on, I think it was Brendan who actually had a question on off-the-shelf products. So bricks and modules. So maybe you can reach out separately to get more details on our existing products.
Absolutely. Anybody that needs to reach out to, you can see the screen here now. You can reach us. That's the easiest way to reach us. I'm sorry, Govi.
So you got another question, Jeff?
Yes, we do. How would you recommend we estimate the weight of your product?
Yeah, I think Reyad actually tackled this earlier on, Jeff. We actually talked about we have the modeling capability and how we actually do, and this was specifically for a warehouse. I believe the question was specifically. I believe Reyad actually covered that as well.
Yeah, I think our thermal simulation and computational modeling tools will allow us to work with our partners to determine the needed amount based on what's the requirement. If somebody wants to have 100% temperature control based on phase change material, it's a different solution than if you have to couple it with an active system. Is it active? Is it passive? Is it an active passive or passive active? All of these, we have the capabilities in-house to work with our partners to estimate the needed amount of PCM to meet the desired out requirement for the project.
Thank you very much, Reyad and Govi. We don't have any more questions, so I would just like to thank everyone for attending the webinar, and we will have the recording sent out to you all. So thank you very much. And if you need to contact us, please contact us at info@phasechange.com. Thank you very much, everyone.
Thank you, Jeff. Thanks, everyone. Thanks, Reyad.
Thank
Bye.
you. Thank
Okay.
you all.
Bye.